Okay, last video we need to talk about the stoichiometry of chemical reactions involving gases. Yes, we're still talking about stoichiometry, and we will for the rest of the year in every unit that we do. So we're going to relate it in this particular unit to the gases involved in chemical reactions. So our gas laws can be applied just like anything else because the reactants and products could be gases. So we're going to be looking at those mole ratios just like we have previously. Okay, so let's talk about volume. When you're looking at a coefficient in a balanced equation, okay, it not only represents the mole of gas, it also represents the volume ratios for gases. So when you're given a mass, you have to convert it to moles or you have to convert it to volume before you can do anything with it, just like when we were doing stoichiometry before. Okay, we've just now added a different way to look at it in terms of gases and volumes. So let's say we have methane. CH4 reacts with two oxygen gas molecules to produce carbon dioxide and two water molecules. Now we can look at our coefficients here as 1 mole of methane reacts with 2 moles of oxygen to produce 1 mole of CO2 and 2 moles of H2O. We could also look at it in terms of volume, which means if we had a liter of methane and 2 liters of oxygen, we would get a liter of CO2 and 2 liters of H2O. So any of those volumes could be liters, could be milliliters, but the ratio is the same as the mole ratio. So let's take a look at how this would work for a particular balanced equation. Okay, now again, like any other stoichiometry, you're still going to have a balanced equation to get the ratio from. Okay. So what volume of oxygen gas is needed for the complete combustion of 4 liters of propane, which is C3H8? Assume that the pressure and temperature remain constant. Okay, so combustion, that should tell you what's going on here. C3H8, which is a gas, reacts with oxygen gas. Combustion means it produces CO2 and H2O, which will both be gases. Okay, we balance the equation. We need 3 C's. We need 8 H's. That makes 10 O's, so we put a 5 in front of the O2. Now we have our balanced equation. So when we do stoichiometry, what do we start with? We start with what's given, and in this case, we are given 4.00 liters of propane, C3H8. Okay. Now, because the temperature and pressure don't change, we can use that ratio in our balanced equation as a volume ratio, just like we could use it as a mole ratio. So, 1 liter of C3H8 will produce, let's see, what are we asking? The volume of oxygen. Okay, so it will react with 5 liters of O2. So our ratio now is a volume ratio, not just a mole ratio. So what that means is we would need 20.0 liters of oxygen gas for the complete combustion of 4 liters of propane. Okay, next example. This time we're going to include mass, and this is going to make it a little more complicated because we can't use mass in our ratio with liters like we could moles. So here we have ammonia is synthesized from hydrogen and nitrogen. It gives us the balanced equation this time, so we don't have to write it. It says if 5 liters of nitrogen reacts completely with hydrogen at a pressure of 3 atmospheres and a temperature of 298 Kelvin, how much ammonia in grams is produced? Okay, so let's figure out what we could do here. So anytime we're dealing with grams, can we get grams from? We can get grams from moles. And because we don't know moles of nitrogen, we know liters of nitrogen, we can't use just straight stoichiometry. But we do have a gas law that has moles in it. What is the gas law with moles in it? PV equals nRT. So if we know the pressure the volume and the temperature, we can solve for moles, and then from moles we can get grams, right? Well, what do we need to figure out? We're given the pressure, we're given the temperature, we're given the volume of nitrogen, but we want to know the volume of ammonia. So we're going to have to do a little conversion first before we use PV equals nRT. So we have 5 liters of nitrogen over 1. And from our balanced equation, we can get that volume ratio from nitrogen to ammonia. So nitrogen goes on the bottom, 1 liter of nitrogen, and that produces 2 liters of NH3. So our liters of nitrogen cancel. That gives us 10.0 liters of NH3. Now we have the P, the V, and the T, and we can solve for the N and know how many moles of ammonia we would get. Okay, so let's substitute in. Here's our pressure. Here's our temperature. We just found our volume, so let's substitute in and solve for moles. So our pressure is 3.00 atmospheres. Our volume, 10.0 liters, equals N times R, and because we're in atmospheres, we can use 0.0821. And our T, it's already in Kelvin, 298. So when we solve for N, we want to have 3 sig figs based on all of our measurements. They all have 3 sig figs, and that would give us 1.23 moles of NH3. Okay, is that what the question asks? No, it asks for how much ammonia in grams. So how do we get from moles to grams? We use the molar mass. So 1.23 moles of NH3 over 1. We have to find the molar mass of NH3. So looking at your periodic table, add up nitrogen plus 3 times hydrogen. That would give us 17.031 grams of ammonia per mole. So our moles cancel, we multiply, we keep 3 sig figs, and we would get 20.9 grams of NH3 from that reaction at that temperature and pressure.